Hello everyone, am I audible? Hello, hello.
Yes,
Okay,
yes.
okay.
Good evening, sir.
So, good evening. I have marked it as a week 4 session, though the week 4 content will be released tomorrow, but I'll do it as a continuation of what the kind of programming I have done on last Friday. So, if you have attended last Friday, so I'll continue with the same thing because week 4, at least the first lecture is a continuation of it. And that is basically the conceptualization of the entire week. The rest of the things are basically application of those concepts, right? The rest of the content of the week. So I'll focus on only on the first lecture of week 4 as a continuation of what you have done on last Friday. So Friday class will have a theory class like what we used to have on usually on Tuesday, right? Okay, so let me share my screen and I want to start with the polymorphism code what we wrote last day, right? So if you attended last day, we discussed the polymorphism. So few concepts we have discussed like we discussed inheritance, how the extend keyword can be used for uh, implementing inheritance. Then we saw how to have an overriding, method overriding. Then we saw dynamic method dispatcher, and ultimately we came to something called as a dynamic or runtime polymorphism, right? So I'll start with the polymorphic code, what we wrote last day, because I want to extend the same thing. So what we have started with, we created a class called as a GeoShape. So as we have discussed, okay, this class will represent any kind of geometrical shape, right? So what I want to say, the behavior any kind of geometrical shape supposed to have, it can have it will have an area and it can also have a volume, right? So I have given two methods to it. So it's a area method and it's a volume method. You can see my screen, right?
Yes, sir.
Okay. Okay. So now until and unless I specify which geometrical shape it is specifically, so I don't know how to implement the area, how to implement the volume, because I should know it is a circle, it is a rectangle, or it's a triangle, what kind of shape it is, right? It's a cylinder. Then only I'll be able to say what is the formula and how it should be implemented. If I just say it's a geometrical shape, I cannot define it. So rightly what we have done, we have given a definition because if I have a method, I have to give a definition. But the definition say actually I cannot do anything about it. So I don't know the actual implementation. Area cannot be implemented. Similarly, for volume also, I can have the same thing. I can say volume cannot be implemented. Now, as we discussed last day, how to understand two classes can have a inheritance relationship. I told there should be an is a clause, right? So I can say a cube is a geo shape. So that means a geo shape class can be, sorry, a cube class can be inherited from a geo shape. So similarly, I can also have a rectangle is a geo shape. Similarly, you can have a triangle also this is a geo shape, cylinder also geo shape, right? So let us have the implementations. If I have a cube, so if I want to say it's inherits geo shape, so I have to write the keyword extends. So extend means what are the codes are there inside geo shape that will be reused into our cube. But I need to extend the geoshape, means I have to write the extra code what should be added with the geoshape code. Now whenever I'm on a cube, I know I can implement the area and volume because cube having a specified width, height, and length, right? So I know the formula exactly how to implement the area and volume. So I can have the formula and I can have the proper implementation. So here I just try to stop a dummy implementation for the time being. But the point is I know the implementation. So I'm not happy with taking that implementation what my parents have given me, right? Sorry, parent has given me. I'm not happy with that because I know how to implement it. So why not? I'll override them, right? So Q will override them. So Q will write, yes, I know how to implement them. So it's a area of cube. Similarly, I'll have a volume. I can have a volume, right? Similarly, if I want to go for implementing a class for a rectangle, extends geoshape. Now, interestingly, I know how to implement an area, but I don't know how to implement a volume, right? So whatever I can do, I'll override that. What I don't know, I'll depend on my parent, right? So whatever the default definition parent has given me, I'll carry on that. So that's how what we have decided will have the implementation of the area, right? And I'll write. So here I wrote both volume. So it should be volume. Okay. So it should be area of rectangle, right? Now this is done. So I want to go for my main code. So I say it is my application code. It's a public static void main. I'll have string args, right? Now I have done it with an array last day, if you can remember. So we have a GeoShape array, which I named as a G. So I say there will be three objects, references of type GeoShape, where G0 will refer to the object of GeoShape, G1 will refer to object of rectangle, and G2 will refer to the object of which one? Cube, right? Now I have done a loop. I've created a loop to do the thing like I have G dot length, right? Then I plus plus. So I called here G of I dot area, G dot I dot volume. Okay. So app is my code. I need to start running it from the app. Okay. Okay. So first for G0, because once I is 0, it's G0, it's referring to GeoShape. So implementation should come from the GeoShape. Its area cannot be implemented, volume cannot be implemented. Now once I will become 1, so now it refers to the rectangle. Now rectangle having a specific implementation for rectangle area, so it's the area of rectangle. But whenever I call G1 dot volume, so there is nothing given over here. So it's by default inherits it from parent. So it gets the parent definition as it is. It's a volume cannot be implemented. Now once I is 2, it is referring to the cube object. So all the implementation will come from the cube. So this is, we have already discussed on last day. Sorry. Okay. Okay. Now we want to further do some analysis with the code. But can you tell me what is the use of this class GeoShape? Why I want to have this GeoShape class? Because it's neither can implement area, neither or can nor can implement volume, right? So why I should have it then? So if you look at here, so the inheritance looks like I have this GeoShape, which is a class, and we have the classes. One is rectangle, another is cube, right? So I have to put a symbol for inheritance, so which will look like this. So it goes upwards, okay? The inheritance symbol. Okay. Now, last day we have already discussed this. In the hierarchy, if you move upwards, so we say it's a generalization. If we move downwards, then it's a
Specialization.
specialization, right? Now, try to understand what I'm saying. You are free to move upwards, but you are not free to move downwards. Why I said so? You are free to move upwards, but not reverse. You are not free to move downwards because rectangle could be typecasted to a geoshape or cube can be typecasted to a geoshape because both are geoshape only, right? If I say rectangle is a geoshape, cube is a geoshape, so geoshape basically is something which share the common behavior of rectangle or cube, isn't it? So that's why anytime you have a rectangle typecasted to a geoshape or cube typecasted to a geoshape. So how do I do it? Last we have done, we had a lot of discussion on it. If you have a geoshape G, you can always have a new rectangle because dispatcher rule was a type can refer to its own object or child object. So that's fine. This is a child object. And we can also have a geoshape G equal to new cube, right? So in first case, a rectangle getting casted to a geoshape. In the second case, a cube is getting casted to a geoshape. Now, this is very interesting. This makes me or this allow me to make the common calls. So I'm making a common call like a geo.area. This is possible because of this inheritance. If I don't have a common class from where I'm inheriting the things, I never can achieve these polymorphic calls. Does it make sense what I'm saying? If somebody is not understanding, please let me know because it will pain you otherwise afterwards.
Yes, sir. Please repeat this.
Okay. So my question was, a GeoShape do not know how to implement area, do not know how to implement volume, but why I should have forcefully given a geoshape class? I may have directly have a rectangle or cube. The answer was, if I want to achieve a polymorphic call, then I should have it. So what we have seen before, that in our last program, sorry, in last program what you have seen, whenever I have this kind of situation, depends on what G points to. Depends on what G points to. So if G is pointing to a rectangle object, then area will be called from rectangle. If G points to a cube, then area will be called from a cube. It is the same call, but depends on where the G is pointing to, the implementation is getting changed, right? Up to this, is it clear?
Yes, sir.
So now, if you want to achieve this, definitely this rectangle and cube must be inherited from a common class. Otherwise, this kind of situation never can be achieved.
Can you
Yes.
repeat this line, please?
So until and unless this rectangle and cube both inherit from the geoshape, a common class, you cannot do this, right? Polymorphic calls. Are you getting? Hello. Are you getting this?
Yes, sir.
Sure.
Sir, to explain this.
Sir, actually here, rectangle is taking properties of geoshape.
Hmm. So that is inheritance.
Yeah, this is inheritance.
But I'm talking about polymorphism.
Okay, what you are saying that G dot area will not give anything.
I didn't told that. I told there will be a fixed definition for G dot area. But here the implementation of G dot area is changing. Depends on where the G points to, refers to. So in first situation, whenever G is referring to a rectangle, G dot area, the area will be called from rectangle. But in second situation, when the G points to an object of cube, the area will be called from a cube.
Okay, okay.
So it is
Now,
the same call, but implementation is changing, right? So that is what I have shown in the code. So if you look at the call, these are identical call, but depends on G0 is pointing to something, G1 is pointing to a different thing, G2 is pointing to a different thing. That's why I'm getting different output for each of these
yes,
calls,
yes, sir.
right?
Right.
Now why this is possible? Because they are inheriting from a common class, right?
Yes, sir.
If I have two classes which do not have any relationship, suppose I have a separate rectangle class and separate cube class. Can you have a polymorphic call like G dot area?
No, sir.
You cannot have a common call because you need to have a rectangle object for calling rectangle area, cube object for calling the cube area.
Cube area.
But since they are inheriting the common class, both can be casted to the common geoshape type, right? So this is what I'm saying. The rectangle and cube both are converted to a geoshape type. And that's why I can make this call, common call,
Yes, sir. Now
right?
got the point.
I'm giving an analogy. Suppose you create a kind of a vague class. I say its name as a playable, right? So now this playable class having a method called play. Okay. Now I implement the class like uh, football. I implement the class like violin, or yeah, I implement a class like a cricket, right? So both can have a play, but their implementation of play will be different, right? If I say I play football, the play implementation will be it's playing a football. If I say playing a violin, it's different. Even playing a cricket is different. But if I create a playable object, say P, and make this P equal to new football, and make P equal to new violin, P equal to new cricket. Now, whenever I'm making this P dot play call, now depends on currently P is pointing to which particular class, the implementation will come from this class. So it is a common interface, right? It's a common call, but depends on where the P is pointing to, it will have different implementation. And why it is possible? Because they are inheriting a common class, right? So you have to remember the points very clearly. If you have an inheritance, then only you can have overriding, method overriding. If you have method overriding, then only you can have dynamic method dispatcher. If you can dynamic method dispatcher, then only you can have a dynamic runtime polymorphism, right? So these are all somehow interrelated. Okay, all okay?
Yes, sir.
So can you repeat
Which one?
uh, the last statement that you made? If you
I
have,
told you need to have inheritance to have overriding. You need to have a overriding to have a method dispatcher, dynamic method dispatcher. You need to have a dynamic method dispatcher to have a runtime polymorphism. Okay. Okay.
yes,
Okay. But Java facilitates you something so that uh, it can reduce your code, and some way it will give you a better programmatic approach or way so that you can write more correct code, correct? Or you do not make a mistake. So the first way it suggested, you can have an abstract class. So before a class, if I say an abstract, then the class becomes a abstract class. Okay. Now points to be remembered about an abstract class. First, it can have abstract methods. I didn't tell you what are abstract methods. I'll go for it. But normal class cannot have abstract method. Secondly, it is must inherit class. So it should be the third point. The second point should be it cannot be instantiated. If I say it cannot be instantiated means cannot have an object. Okay.
Sure.
The first I say it can have abstract methods. Now the question comes, what are abstract methods now? Abstract methods are methods without implementation. So I don't have to implement them, right? So I'll go one by one. The first thing, if I decide that I'll make this volume as an abstract, then I don't have to define it. I can just declare the method. I just declare the method. I don't have to write the definition of it. Have you got what is an abstract method? Have you got what is an abstract method?
Yes, sir.
So we don't have to define it, right? So whenever you have an abstract class, you can have abstract methods. Normal classes cannot have an abstract method.
Sir, what does abstract class do? Like, what's the
I'll go
function?
for that. Yeah. So first thing is abstract class can have abstract method. Okay. So what is abstract method? Abstract method means you don't have to implement it. Up to this, is it clear?
Yes, sir.
Yes, sir.
Now check out the second point, which says it cannot be instantiated. It cannot have an object. Why? So I'm saying I cannot write geo shape g equal to new geo shape, because if I say g dot volume, what it will give?
Nothing.
Huh?
Error.
It do not know what to give, right? So it is an incomplete class. It is an incomplete class because you are allowing some methods which are not having the definitions. Because you are allowing some methods which do not have a definition, right? So syntactically, Java prohibits us, okay, we cannot have an object of GeoShape, because if you create an object and you call a method which is an abstract method, then it is very wrong, right? Because you haven't implemented something you're calling that. That's never possible. So that's how, since abstract classes are incomplete classes, we cannot create an object. Anybody want to tell me what is the answer for the second one? It cannot be instantiated or cannot be created object. Why?
Same reason, sir.
Can you tell me? Repeat it.
Because if you create an object and you call the abstract method which has no implementation,
Yeah,
what should
it
be
will
the
fail. It will fail definitely, right? And since I'm allowing the abstract methods to be there inside abstract class, so Java syntactically prohibits me that I cannot have an object of abstract classes. Okay.
sir?
Huh?
So I've got a very silly doubt.
Yeah.
Sir, can you just please move back to that the slide which you have written? So the second statement says it cannot be instantiated.
Hmm.
The problem with this term instantiated is that I think it is related with instance. Though we use it for object creation, but
Classes. What is instance of a class?
it can be its own object or object of its child as well. Because the thing
I'm
is,
coming. Yeah. What you're telling? I'm coming back to that. Yeah. So
okay,
that I'll discuss in third point. I got it. What you're saying, it's correct. So what is the third point says?
There
It
cannot be an
must
instance variable.
Third point say it must.
inherit class.
It cannot have instance variable, right?
It
Third point is
is a must.
Second,
Inherit
third
class.
point, okay.
No,
I've
this
not
is
been
third.
numbering.
I have written three. Yeah. It is must inherit class. What does it means?
So it must inherit from the child should inherit from the
Yeah. So abstract class you
parent.
cannot utilize, right? Until and unless you inherit something from it.
Yes.
Because you cannot create an object, right? So until and unless you inherit something from this class, there is no use of an abstract class. Right? It can be only used for inheritance. It could be a parent, somebody inheriting from it. Otherwise, what is use? Because I cannot create an object, so how do I use it? Right? Got the point, right? Anybody still have confusion?
No, sir.
Okay, okay, okay.
Sir, could you please repeat second point?
So second point say it cannot be instantiated. Cannot be instantiated. Sorry. It cannot be instantiated. Or you cannot create an object. So what I told, since it allows you to have abstract methods, and abstract method do not have any definition, right? Implementation. So what if I create an object of GeoShape and try to call the method, which don't have the implementation, means it's an abstract method. It should be a failure, right?
Yes, sir.
So that's why syntactically it's prohibited, because you are actually intentionally allowing the methods to not have the implementation. So why you want to have an object of it? Now, if I cannot create an object of a class, then what is the use of the class? Until and unless I have an object, how do I call its methods, right? But yes, it can be used. It can be used through inheritance. Suppose I use cube to inherit the GeoShape. I cannot write GeoShape G equal to GeoShape because that is prohibited, because I cannot have an object of abstract class. But what I can have object of the cube class, right? Because cube class is not an abstract class, right?
Yes, sir.
Yes, sir.
So more clearly saying, an abstract class cannot be directly instantiated, but can be instantiated by its child class. Right? I cannot have a direct object of a abstract class, but I can make it inherited by a class, and I can have object of that class. So object of cube class is nothing but my own object, right? It will become my own object. So that's why whenever you are having an abstract class, you cannot realize its object until and unless you do inherit it. Until and unless you do inherit it. Up to this, is it clear?
Yes, sir.
Yes, sir.
Everyone clear, right?
Yes, sir.
Okay. So I assume everyone is clear, because next
Yes, sir.
decision making I'll go for. Okay. So every step is crucial. So if you don't understand the first step, you cannot understand the second or third step. So the next step, the decision making. So I had this initially, right? Now, as I told, in abstract class, you can have abstract method. You can also have a normal method. Normal method means normal, like void area something, right? But how do I decide which method I'll make abstract and which method I'll make it normal?
This is constant for everyone, that should be normal, and which is changing, that should be abstract. Uh,
I cannot make everything abstract, because there should be some way I do understand which should be abstract and which should be a normal. So how do I decide? which should be abstract and which should be normal? See, if it is a normal, right, then I need to write some definition. Agree?
Yes, sir.
Yes, sir.
Then for my child class, it is not mandatory to overwrite it. If child class wants, it can overwrite it or may not overwrite it. Agree?
Yes,
Yes,
sir.
Yes.
sir.
So like rectangle, I have overridden the area but not overridden the volume. Right? So for normal method, it is not mandatory that you need to override. But if I write something as an abstract, what will happen? It won't have a definition. Now, whenever you are writing a child class, you need to give a definition, right? Otherwise, you cannot create even the instance of the child class also. Getting my point? If you
Yes,
define
sir.
Yes,
something
sir.
as an abstract, you must be defining it inside your child class. Otherwise, for child class also it becomes abstract.
Yes, sir.
So, one more point we gets over here that abstracts are must override. Means if you have an abstract method, you must override that. Means your child has to override it. Otherwise, your child class also becomes an abstract class. Okay. So what I understand, if I keep it as a plain method, then overriding is an optional. But if I make it as an abstract, then override is mandatory. Now, can you tell me in GeoShape I'm having this method area and volume. So how do I understand which should be my abstract, which should be normal?
So child class, both the child class will be normal because they'll be overriding the abstract
Yeah,
class.
yeah. So as a parent, if I'm sure that all the childs are going to override something, then I can make it what?
Parent will be
Abstract.
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 See, if I'm sure that everyone will override it, I'll make it abstract. But if I'm doubtful, somebody can override, somebody cannot override, then I'll make it normal,
Normal.
right? Now see, whatever shape it is, it will have an area, right? But for rectangle, I may not have a volume, right?
Yes, sir.
So which one should be abstract, which should be my normal?
Volume is abstract.
Which
Volume
one
should
is
be
abstract?
abstract.
Area should be
Volume.
Area
abstract.
should be abstract because I'm sure that everyone will have an area. So
Yeah.
everyone will implement it. So why I should give the implementation? So I can rather reduce my code, right?
Yes, sir.
Everyone give me the implementation, so I have to do it. But volume may not be there. So if I don't implement, who will get the definition? Like how my child will get a definition if he's not overriding it? Okay. Now remember, it is mandatory for your classes to implement the area. If you don't implement it, then it's a error because your area is a abstract method, right? So area is an abstract method, so that must be spelling I have put. So
So that means both the child should have area as a normal method.
1 minute.
Even if
Everywhere I have written abstract spelling. Yeah.
even if one of the child does not have
So
the area,
the
then it will give an error.
name is wrong. File name is wrong, I think.
No, file name is app. Correct. See what it is saying. The first error. Rectangle is not an abstract and does not override the abstract method area. What does it means? Either you have to mark the rectangle as an abstract class, or you need to override area, right?
Yes, sir.
And what is the second error says?
We cannot create object
Object
of
of
geoshape.
geoshape
Geoshape.
because it is an abstract class. So whatever I have written, all are true, right? Yes, somebody was saying area must be there in all the child classes implementation, but I may skip the implementation of volume. Yes. Now I need to reduce it to 2 because this is not possible now. But I can have this and this. Rest of the implementations remain the same. I'll write it as a app. Okay. Okay. This is clear, right? One point again, very important. I cannot extend more than one class or abstract class. So you cannot extend multiple classes. It may be normal class or an abstract class. So you have to always inherit only one class. It may be an abstract or an normal class. So next, I'll go for much stricter implementation, which calls as an interface.
So can you please go back to the code? I joined late, so the last class app, in that you have created an object of geo shape. So is equal to 2. So why we are creating, since we are using an abstract, so why I didn't get that?
This is not creating an object of geoshape because I haven't called the constructor. This is creating reference of geoshape type. So
Okay.
last time we had a quite long discussion. It creates an array of G type, geoshape type. So this is 0 and 1 index. So this is a reference which is pointing to an object of rectangle. And this is pointing to a
Cube.
So this is not creating an object. This is, if you want to create an object, you should have called to a constructor. So this is creating an array of geoshape class. Okay. Okay.
Okay, yeah.
Yes, sir.
Okay. So I'll move into interface. So I say it's a much strict implementation. In classes, whenever I have a normal class, I must define every method. But in abstract class, I can have normal method as well as abstract method, which I don't have to implement. In another way, I say if it is a normal method, I can say what I can do and how to do. Right? That means I know I can have area, I can have volume, and I also know their implementation. But if you go for an abstract class, you know what to do, but sometimes you know how to do. Right? So for normal methods, you know the implementation, so you know how to do it. But for abstract method, you know what to do, but you do not know how to do it. Got my point?
Yes.
Now, whenever I say an interface, then it's a kind of a class which can only say what to do, never can say how to do it. Means all the methods are abstract. All the methods are abstract. So this is much strict implementation than a abstract class. It says all the methods are public abstract. All the methods are public abstract.
Abstract.
Okay. So, what I want to do, I want to make a geoshape as an interface. Face. That means I want to make it mandatory. All the geometrical shapes should have an area and volume. All the geometrical shape should have area and volume. Even I don't write this public abstract, if I just write this and this, I cannot have normal methods. So they will become actually like public abstract void area. So by default, they will take it as a public abstract. So nothing could be defined or implemented inside a interface. Okay. Now, why it is strict? I say because it will enforce you. You need to implement exactly the things which are declared by your interface. It forces you that you need to implement all the things you have inside an interface. So now in this case, let me save the previous code. Okay, I haven't saved it. Okay. Yeah. So I said I do interface. I do say okay. If you don't even write it as a this, they become public abstract void area. There is no way you can have a normal method, means you cannot have any implementation over here. Okay. So for interfaces, we don't say it's a extends, rather we say implements. Okay. And since both are abstract by default, you need to have both the implementation. For rectangle also, you cannot skip volume. Here you must have some implementation. So maybe for volume, you can explicitly say cannot have volume, right? Now implementation wise, they are very much same as an abstract class. So again, like an abstract class, you cannot have an object of interface. The same reason, because no implementation is given. So if I can create an object, how do I call them, right? But you can realize it through the child object. So you can have the child object as well, and you can run it. So I'm getting the implementations.
But then here we don't have overriding, since we are using the child class should have both the things, area and volume.
Rather, I must have overriding. All the child must override area and volume. They must implement, right? Because
But
Sir,
we
parent
have
is not given. Yeah,
but
in that way you're
we
saying
have to mention the area and volume in child class also. In
yeah, that is
previous
what I'm saying.
abstract, we
Like
did
it is
not
a must.
mention.
It is a must override situation. It is a must override. Since my parent is not giving it, I must do it. Right?
Oh,
Yes,
okay,
sir.
yeah, I got it. Yeah.
If parent is
You are
giving
saying
me, I may override it, may not override it. Since my parent is not giving me, I must overwrite it. So abstract class is must inherit. Abstract method is must override. Got it?
Yes, sir.
Sir,
Yeah.
then in long code or in programming, then
What?
why will we do implementation of GeoShape if we are giving all the method in my component?
Again, you're there whenever I show this hierarchy. This is because I want to achieve the polymorphism. So this polymorphic call is achieved. If I want to have a normal class, I need to write some unnecessary code which is actually not required. But in this case, I don't have to write lot of implementation for area and volume, which is actually not useful. But still I can have polymorphic calls. So if you're not there at the beginning of the class, maybe you can check out the YouTube recording. We've discussed it. Like why I should have a class on the top.
Yes, okay, sir.
Sir, why we are using implement?
So this is a syntax like for class and abstract class, we write extends, and for interfaces, you will have implements. There are something you need to remember. I'll just write it. It's just a way to how do I present it. So if you have an interface, sorry, if you have an interface, from interface you can implements an abstract class or a normal class, right? From interface, you can implement a abstract class and normal class. So you have already seen that normal class is implementing an interface. Can you tell me how an abstract class can implement an interface? Suppose I don't want to override all the methods. Few methods I want to override, few methods I don't want to override. Suppose I have this interface. Now I want to have a class I'm writing as a test, which will define the area, but will not define the volume. But definition of volume is an abstract, right? So I must define it. But I can keep it as an abstract class and make it implements GeoShape. Because if I make this test as an abstract method, then area is implemented, so it becomes a normal method and volume remains as an abstract method. Got it? So an abstract class or a normal class can implement our interface, but an interface can extend another interface, right? From GeoShape, you want to inherit a interface, which is now named as an 3D. I cannot start with I say D3 GeoShape, suppose. Like 3D GeoShape, I mean to say. So in this case, I need to write extends GeoShape. So interface to interface is a extends. But interface to abstract class or class, it's a implements. Now if you have an abstract class, from abstract class you cannot inherit an interface because an interface is a must triggered one. From abstract class you can have an abstract class inherited. So that's a extends. From abstract class, you can also inherit a normal class. That's also an extends. Okay.
Yes.
So maybe we can stop here. You can go through up to this. Then Friday we'll have the theory discussion. Maybe Saturday I'll again take. I'll continue with from there. This part programs kind of.
Sir, one question I had.
Yeah. Yeah.
So, like in our calendar, there is this dates mentioned about,
Huh.
but we don't get any notification. I don't know why. For other things, we are getting notification. Like for some, when some house meeting happens, there is a notification that we have got something. But for this live sessions, I don't know it is my problem or everyone else, but I don't get any notification key live session has started. And I am actually working, so
Okay, I
little
got your
difficult.
point. Means okay, okay. I also don't know. I have to check it with Obstin.
Okay.
We don't get notification. We
I
see in
think they have
calendar
added
and
you
then
as a
calendar
group.
as
I
per the
think
timetable, we just click on it.
no. I think I got your point. I think they have added you as a group. That's why you are not getting. But anyway, I'll check it out. Okay. I don't know.
Okay.
I'll check it out. I'll let you know. Yeah, Prasant.
So in the beginning, we discussed why we need a common type geoshape
Yeah.
to define rectangle and cube.
Huh.
Like I have one more reason. So
Yeah.
is that reason correct? So like another reason is that geoshape is like a parent type. So
Yeah.
and we have its subtype like rectangle and cube because it inherits from that,
Yeah.
extends that. So that is why we can put it inside a single array, like array of
Yeah.
geoshape.
Yeah. That is what I'm reason. Okay, they are all castable to your common type, right? You're
Yes, sir.
making your subtypes are castable to your original type, right? Because this is what the term say. So I say rectangle is a kind of a shape. I say triangle is a kind of a shape. I say cube is a kind of a shape. So they're all castable to shape, right? So I'm having a common type to converge. So that's why this common call is possible.
Yes, sir, and that is why we can put it inside the single array
Yeah, it's
of
because I can have a
geoshape.
common type. That is all the reason.
Otherwise,
Speak.
if rectangle and cube were of different types, we can't put it
Yeah,
inside same array. Right? It
because
should be
I told
homogeneous.
last day this upcasting is always allowed, right? So you
Yes.
can convert any child type to its parent type. So we are
So
basically exploiting that feature.
it's because of polymorphism, right?
Polymorphism is the output of the thing, what I'm getting,
Yeah.
right?
Yeah.
It's a
Like
result.
different classes of maybe there's a super class and then subclass there, and they want to
It is the
kind of
principle
use
of
it.
dynamic method dispatcher, right? Which
Yeah.
says
Yeah.
that,
Yeah.
yeah,
Dynamic dispatchment.
yeah, yeah. Anything else?
So, but otherwise, we can also put rectangle and cube as separate data types, and it can
But
still
you
have
cannot
area.
convert into a common type, right? If you cannot
Yes.
convert to a common type, how do I make a common call?
Okay, then we can run the for loop.
A polymorphic call I cannot make. I can call them, but I need to call them separately.
Yes, sir. One by one, rectangle
Um,
and cube objects.
Yeah.
Hello, sir.
Yes.
So actually, I have a doubt in one of the PPA questions, which involves the use of equals and two-string methods.
Yeah.
Sir, have you already explained the use of the methods?
Two string I have explained.
Okay,
Equals method. Can you remind me on Saturday? I'll do that.
okay, sir. Sir, actually, I was not able to override the equals method. That's why I said
I'll
that.
show you on next day. Okay.
Okay, sir.
And I'll do more detail whenever we'll go in week 5, I think, where we had this hash map and all. Because this hash code also is an important function and it's somehow related to equals. But I can separately show you the implementation of equals. Just remind me on Saturday at the beginning itself. I'll do that.
Okay, sir. Okay.
Okay. Anything else?
So next class you will take on Saturday, right?
Yeah, Friday will be the theory.
Friday
That
will be theory. So
concept
like,
is
is it happening every week? Because today actually I saw the calendar thing, so I was a little aware ki there is a class there.
we postponed it last Saturday class actually, but otherwise all three classes happens.
Okay. Yeah. Okay, sir.
Okay.
Sir, could you please discuss a second question from practice assignment?
Can you share it? I don't have it. Shall I
Oh,
stop this recording?
yes, sir.
Yeah, you can share it then.
So it's getting recorded also, or like it's just
Ha,
gonna
it
be
is
one?
getting streamed on YouTube. You can get it on the YouTube.
Okay.